All right, welcome back to Historical Geology. Today I want to continue on with Chapter 18, looking at the placental mammals. So the placenta in mammals provides oxygen and nutrients to the growing baby and removes waste products from the baby's blood. This placenta attaches to the wall of the uterus and attached to the baby by the umbilical cord. Now the other big part is the amnion of the amnion egg, and that's what fuses to the uterus and provides this fluid-filled sac sort of as a shock absorber to the embryo. The thing about the placenta is that it allows the fuller development of the baby in utero. So when the baby comes out, it's fully developed, as opposed to the marsupials where the baby looks like an embryo when it makes its way up into the pouch. Saying that, about 90% of mammals are placentals, and there are about 18 living orders. Now, during the Paleocene, several mammal orders survived this Cretaceous extinction, so we call those some of those archaic mammals. Now, looking at the new placentals, we have the rodents, the rabbits, primates, carnivores, and then two groups of hoofed animals, or ungulates, the Artiodactyls and Perissodactyls. These would be the even-toed Artiodactyls and the odd-toed Perissodactyls. We'll say more about these. But I also want you to note the orders of rodents for Rodentia, then Lagomorphia for rabbits, and primates for the primates. For the carnivores, which includes dogs, cats, bears, weasels, seals, sea otters, all those are the order Carnivora. Now here's a picture of one of those archaic mammals, multitubulate. These went extinct in the Eocene. Looking at the Eocene mammals, so remember, this is a time when there's lush forests, it's humid, it's semi-tropical up to higher latitudes. There's a famous fossil bed site in Oregon called the John Day Fossil Beds, and here there are several fossils found of titanotheres, rhinoceroses, carnivores, early horses, tapirs, a whole variety of species that lived during this time when it was subtropical and we had the lush forests. When we move to Oligocene and Miocene, so the boundary between Eocene and Oligocene is about 34 million years ago, 33.5 million years ago. We start seeing more of these savanna-type grasslands where those large ungulates like titanotheres go extinct, but we have some other large mammals that develop as well. The horses start advancing. They go from having 3 to 4 toes down to 1 toe. So they start progressing. So here, in fact, we read about this or did a little video assignment on Ash Falls fossil bed site in Arkansas. And so we had the one-toed horses, small camels, turtles, rhinoceroses, cranes, giraffe-like camels. So a variety of species were living in North America during this time. For some of the rodents, here's Paleocastor, which is a 30-centimeter long, late Oligocene land-dwelling beaver, and it would make these corkscrew burrows, and that would fill up with sediment, referred to as the devil's corkscrew. But rodents comprise about 40% of all living mammal species. They evolved in the Paleocene and have since adapted to a wide range of environments. So the question is, why were they successful? Remember, these guys can eat just about anything. They're very successful. Here is an interesting rodent. They call it Ratzilla from South America. This had a pair of horns on its snout. The smallest mammal was so equipped, about 30 centimeters long, which is a little over a foot long. And so it lived from the Miocene to the Pleistocene time. And then for the lagomorphs, the rabbits, here they resemble rodents but have anatomical differences. The key thing is they have these different teeth and they have hind limbs that evolve for running and leaping. For the Chiroptera, which are the bats, the oldest fossil is from the Eocene in Wyoming, except for wings closely resemble shrews. And they have these 4 long fingers. You can see these 4, and then that held together that wing there. And then for primates, well, we have several groups that belong in this order primates. It includes prosimians, which include the tasirs, which are this guy, the bush baby, lemurs, mostly from Madagascar, and the lorises, mostly from India. The other group are the anthropoids, which include the monkeys and the apes, or the great apes, so including humans. And by late Cretaceous time, they were starting to evolve, as we noticed earlier. They began small in the Eocene, and this is dealt more in Chapter 19. We really won't have time to go over them, but if you have time, you should read a little bit about some of these hominids. For the carnivores, remember, they're going to have these specialized teeth, the carnassials, and they're also going to have these prominent canines for capturing or really biting down prey, and then the carnassials are more for shearing the flesh. So the order Carnivora includes bears, seals, weasels, skunks, dogs, and cats. For the marine carnivores, there's polar bears, seals, sea otters. Those are all examples of these carnivores. And again, they all eat meat, but they all have an extremely varied diet. And saying that the order Carnivora began to diversify when two distinct lines evolved, and the first one are the creodonts, and the other one are the Miacids during this Paleocene time. So remember, Paleocene time is going back to about 55 to 65 million years ago. The creodonts have gone extinct, so we won't really deal with them too much. But the Miacids, these are the ones that led to all modern carnivores. So here's a picture of an early Miacid. So today's carnivore mammals evolved from a primitive group known as the Miacids. So this is a coyote-sized Miacid from the Eocene. So all weasels, otters, skunks, badgers, martens, wolverines, seals, sea lions, walruses evolved from an ancestor that looked very much like this coyote-sized Typhlosan. Dogs may have evolved before cats, so dogs evolved in the Eocene. They resemble hyenas, but hyenas are more closely related to cats. Cats evolved in the Oligocene, but cats really developed these sabers really by the Miocene time. That makes them really a famous fossil of the Miocene and Pleistocene epochs. Now looking at the ungulates, so remember I said there's two groups. There's the even-toed ungulates called the Artiodactyls, and the odd-toed ungulates known as the Perissodactyls. So for the Perissodactyls, we have horses, rhinoceroses, and tapirs. Whereas Artiodactyls include cattle, goats, sheep, swine, antelope, deer, giraffes, the hippos, camels. Artiodactyls are the more abundant group, but earlier in the Cenozoic, Perissodactyls were more abundant. Looking at kind of the shape of the foot, here's a horse, one toe, rhinos, three toes. For the Artiodactyls, pigs have 4, camels have 2, cows have 2. We saw that the Entelodonts also had 2. And then we also talk about the teeth shape and the molarization. There's premolars become more of these grinding teeth. Remember, grazers are eating grasses, so they have the higher crowned cement teeth, right? High crowned teeth, cement covered, chewing. Hoofed animals are diet as grasses, whereas browsers are eating leaves and twigs, so they're going to have the low crowned teeth. So these are the primates, pigs, many other mammals, and they have a varied diet. For the Artiodactyls, most are going to be these ruminants, so the ones that are kind of have these 3 or 4 chambered stomachs. They have that chewing, that cut chewing, the ruminants. But we also talked about some of the earlier entelodonts and carnivorous ungulates. So eventually that these, in fact, hippos, peccaries, pigs, entelodonts, and we could even fit in here, there's a group that eventually lead to the cetaceans. And for Artiodactyls, the family Bovidae is the most diverse. There's many species. There's cattle, bison, sheep, goat, antelope. For the Perissodactyls, horses belong, and horses really have a long, well-documented fossil record in the Cenozoic. Here, the first earliest horse, Hyracotherium, actually had 5 toes here, 5-toed horse, and they evolved to eventually go to 4-toe, maybe 3-toe on the front, 4-toe on the back, each toe covered by a small hoof, and eventually over time they led to single-toed in modern horses. In fact, this next one kind of shows this long evolutionary history. There's one where we had a branching with numerous species, one that was mostly eating branches, and there were browsers, branches and leaves, whereas another group started eating more grasses. Remember, by this Oligocene Miocene time, we started seeing more of the steppe or grassland savanna type environment, where browsers went extinct here, but the grass-eating horses really developed. And in fact, the modern genus is Equus. And you can see that we have them still in the Old World. So in terms of North America, they went all extinct back in the Pliocene, early Pleistocene. But the modern horses really started in North America, and the ones we see in the Old World migrated along that Bering Land Bridge back toward the Old World. So what are some of the trends in Cenozoic evolution of the present-day horse? So we can read about these, but mostly what I want to show here is there was a hornless Oligocene Miocene Asian rhino, and it's called the Indricotheres, although here they call it the Perissodactyls, and it was the largest land-dwelling animal or mammal that ever lived. And you can see, compared to a modern African elephant, it was a ginormous mammal. Other mammals of the Paleogene and Neogene include the Chalicotheres, which had these claws, and then also Titanotheres that went extinct in the Eocene. So again, they're going to be the odd-toed mammals. Then for the family Proboscidea, which include the elephants, mastodons, and mammoths, so you can see that there is kind of a long history here. And then now we have the mammoths, American mastodon, surviving into the Pleistocene. And then today we have elephants and the Indian elephant, African elephant surviving today. Mammoths evolved in Pliocene and Pleistocene, lived in Africa and all northern continents until the end of the Pleistocene. So here are the Columbian mammoths. So they also lived in North America as well. And for the mastodons, they became extinct only a few thousand years ago, evolved in Africa. One genus reached South America. So they were a little bit shorter, had kind of a longer brow, not as tall as a Columbian mammoth. Now looking at the aquatic mammals, blue whales exceed 30 meters long and about 130 metric tons. The sea cow, order Sirenia, and the whales, order Cetacea, are totally aquatic, but they once started from sort of an ungulate artiodactyl ancestor that went back to the ocean. By the Eocene, we see the Eocene ancestor whale was a small land-dwelling artiodactyl. And here we're seeing sort of a cladogram of the whales. So today we have the Miacids, which are the baleen whales, and the Odontocetes, which are the toothed. And you can see that over time, we're going from some land-dwelling artiodactyl that really branched off into what we see the modern hippos, and we also see the development of these different early whales. One of the more important ones we see in the fossil record is Ambulocetus, which means walking whale. And then the other important one is Basilosaurus here, which had little hind legs down here that eventually led to our modern whales. So even our modern whales have those vestigial hip bones in their fossil skeletons. So for the aquatic mammals, the front limbs modified into paddle-like flippers, hind legs disappeared, nostrils migrated to the top of the head, the horizontal fluke evolved for propulsion, and then we talked about the Ambulocetus and Basilosaurus. Now here's a picture of both Ambulocetus and Basilosaurus. An interesting whale that developed in the Oligocene is Artiodactyls, and this whale had both baleen and teeth, and its nostril was halfway between its snout and the top of its head. So it's kind of an evolutionary step between the early Ambulocetus, which had nostrils at the front, and now modern whales have the nostril or blowhole at the top here.